Hello, Doctor. My name is Din Ajami, and these are my team members, Nancy Faris and Eliana Abu Khalifa. We would like to express our thanks to Dr. Saeed Jabir for guiding us through this project. Our database project is called Emonet. It is a system designed to track and analyze a person's emotion through smart devices. So the system is modeled as a mobile application when users interact with smart devices that capture emotion data and generate recommendations based on the detected emotions. A two-tier database architecture is suitable for this application, consisting of a client layer and a database server layer. Emonet is a system that is designed to track and analyze a person's emotion based on factors such as the location, the current activity, and the emotion the person is having. And this all is recorded through sessions. And according to these sessions, there are recommendations that are given to users to help them undergo this emotion. Today we will walk you through the components of this database, the ERD and the mapping, the SQL queries, and our documentation showing you how everything works together.
Role of each component. User client, it represents the mobile application. It allows users to view emotion readings and see activities and recommendations. Now, database server. This layer stores and manages all data. It handles users, devices, sessions, emotions, locations, activities, and recommendations. It also enforces data integrity and executes SQL queries. We used MySQL for our DBMS. Today I will talk about data modeling in the emotion system. Database modeling helps us turn system requirements into structured data, showing how information is connected. The ERD is a clear picture of these connections. In the emotion system, users register with the email, name, birthday, gender, and a preferred language. Each user can have one or more smart devices monitor emotion during session. Each session records emotion readings over time, including the type of emotion, its intensity, and how confident the system is. Emotion readings are linked to users' location. Sessions are also records user activities based on the emotion. The system can provide recommendations. This modeling helps the system store, track, and use data efficiently.
Now going to the ERD diagram. So first I will explain the first entities in our Emonet database, which are the user, the device, and session. The user entity represents the people using the system. Its primary key is the user ID, and it has attributes like birthday, email, gender, name, which is composite, and language, which is multi-valued. Going to device, the device entity represents the devices used to access the system. Its primary key is device ID, and it has attributes like dname, dtype, model number, and status, which can be active or inactive. A user can have multiple devices, but each device belongs only to one user. This explains the relation between them, which is a one-to-many relationship where a user owns many, but device is only owned by one user. Now, going to the session entity stores the sessions recorded by the system. It has a primary key called the session ID, and it has attributes like purpose, end time, and start time. This entity has a one-to-many relationship called used in with the device entity, since a device can be used in many sessions, but one session is only recorded in one device. So in summary, the user entity connects to device and device connects to the session, showing how users, their devices, and sessions are linked to the system.
The emotion reading entity represents the actual emotional data collected. It's a strong entity. It has ERID as a primary key and timestamp as composite attribute. In this entity, one session captures many emotion reading, and each emotion reading belongs to one session only. The emotion entity, it stores predefined emotion types. Entity has emotion ID as a primary key. Each emotion reading detects one emotion. One emotion can be detected in many readings. This avoids duplicating emotion data. Location entity represents the environment where emotions occur. It has location ID as a primary key. Each emotion reading occurs at one location. One location can have many emotion readings. This helps analyze environment impact of emotions. I will explain the ERT how these entities are mapped to tables. I will focus only on three parts: emotion, activity, and recommendation. The emotion entity stores the emotion detected by the system. Each emotion has an emotion ID, which is the primary key. It also has a name, category, and intensity level. The activity entity shows the user's action during a session. Each activity has an activity ID as a primary key, an activity name, and a category. Each activity belongs to one session, and one session can have many activities. The recommendation entity stores a device given to the user. Each recommendation has an recommendation ID as a primary key. A type and effectiveness level. Recommendations helps user improve their emotional state.
Now we're going to mapping ERD to database schema. First, I'm going to start with the user table, which has a primary key of user ID, and it has other attributes like gender, F-name, L-name, and other things. Then we have the user language entity. The user language entity is a multi-valued table representing the languages each user knows. A primary key is the user ID, which is a foreign key taken from the user table, and the language. It, they both represents the primary key, which we call a partial key. So each one of them is a partial key. And we also have the device table. The device table represents the devices used by users. Its primary key is the device ID, and it has other attributes, and it also has a foreign key, which is the user ID, which also tells us which device corresponds to which user.
Emotion reading captures emotional data during sessions and link to the emotion entity, which defines emotion types. Location stores environmental context. The emotion entity stores predefined emotion types and their categories. It is referenced by the emotion reading entity, which records when an emotion occurs along with its intensity and confidence during a session. This separation avoids data redundancy and ensures consistent emotion classification. After data modeling and ERD design, each entity is covered into a database table. Emotion becomes the emotion table, activity becomes the activity table, and recommendation becomes the recommendation table. In Chapter 3, we build the database using MySQL by creating tables with DDL scripts. Each table has a specific role, and relationships are defined by using primary keys and foreign keys. The users table stores basic user information such as email, first name, last name, gender, and birthday. Each user is uniquely defined by user ID, which is the primary key. Device table stores smart device details like name, type, model, and states. Each device belongs to a user using user ID as a foreign key. Session table store monitoring session including a smart time and time, propose, and device use. Emotion table define emotion types such as calm or happy with the category and intensity scales. Location table store where the emotion was detected like place, type, and atmosphere. Emotion reading table store the actual detected emotion during session including time, confidence, and intensity. and links, sessions, emotions, and location. Activity table records user activity during a session. Recommendation table store recommendations, types, and effectiveness. Recommendation reading tables store the actual recommendation text generated during session. Finally, user language table stores the language spoken by each user.
The next step is using DML scripts. First, we're going to start with the data insertion. To test the functionality of our database, we use insert queries to add sample data into the tables. This allows us to populate the database with realistic records so that we can execute queries and verify the relationships between the tables. Here, we are inserting values into the table users. The values correspond to the attributes defined in the data schema, including the primary key and other relevant fields. And the same is done for all the other tables.
Now let's talk about data modification and deletion. We implemented several update and delete queries such as updating user emails, changing devices status to inactive, modifying session purposes, updating emotion intensity values, editing recommendation text, deleting activities, emotion readings, and recommendation records. These operations demonstrates how the database supports real-world changes in system data.
Finally, we have the set of relevant extractions and queries. We tested the database using SQL queries. For example, here we have display all user information. This SQL query was used to retrieve all the user's information. For example, we also used display all types and effectiveness. Here we also selected the effectiveness of the type of recommendation, and also the output is the type and the effectiveness. We also used some complex queries like here, display all user uh, activities in the education and entertainment category, including user and session details. Here we also use Union to get the result and the output of our query. So these queries verify that our database works and how it's essential and beneficial in many ways.
In conclusion, the Emonet system was successfully designed and implemented using structured and professional approach. This project demonstrates proper database modeling, clear EID design, SQL implementation, practical application of database concepts. The system efficiently manages emotional data, smart devices, and user interactions, making it suitable for a real-world emotion monitoring application. Thank you for listening.